Hello friends, welcome to my channel Control System Engineering. I, Professor Darshan Thakur, is going to explain this graphical representation technique by which we can determine the transfer function of that given system. So the name of this technique is nothing but signal flow graph, right? So with the help of this example, we will go through this technique. So first of all, we need to understand the objective behind this graphical representation. So the objective is like this: obtain the gain of this following system by using Mason's gain formula, right? So one question arises in our mind ki why the name given to this formula as a Mason's gain formula? Because see, the answer is very simple for that question ki we need to determine the overall transfer function of that system, right? So the transfer function is nothing but what? First of all, we need to understand that this transfer function is nothing but it is the ratio of output to the input of that system in terms of S domain. That is nothing but transfer function. So this methodology is being invented by this fellow whose name is nothing but this Samuel Mason. So on behalf of his invention, the name given to this formula is nothing but Mason's gain formula, right? So first of all, we need to understand that formula, then and then we can determine the overall gain of that system, right? So this Mason's gain formula is being used to determine the transfer function, that is nothing but what? The ratio of output to the input. C of S upon R of S is nothing but transfer function. So the Mason's gain formula equals to, it is 1 over delta into summation of Pi into delta I. One by one we will try to discuss all the things belongs to this Mason's gain formula. First of all, as you can see, this we are having the summation sign. So the summation sign is being iterated for ith number of time. So one question arises in our mind, what this P suffix I stands for. So this Pi is nothing but it is the gain of ith number of forward path, right? So first thing we need to determine here is how many number of forward paths we are having with us. Forward paths. So forward path is nothing but how we can complete our journey from input to the output. In this graphical representation is nothing but forward path. So we can have the n number of forward path, and the gain of each and every forward path is denoted by this abbreviation called it is as a P suffix I, right? Then after that another notation which is present in this Mason's gain formula is nothing but this delta, right? So in mathematics, this delta that can be called it is as a determinant. So similarly here, this delta is nothing but system determinant, right? So how this delta is being tabulated? This delta equals to 1 minus P11 plus P21 plus P31 like this, plus within this second parenthesis it will be P12 plus P22 plus P32 like this, minus third term will be P13 plus P23 plus P33 like this, right? Now one question arises in our mind ki what are the terms those are being written within these three parentheses. This will be the first one, this is the second, and this is the third, right? So how to get this delta? Delta equals to 1 minus P11, P21 and P31. Whatever the terms those are being written within this first parenthesis, that terms can be called as it is the sum of gain of all individual loops, right? So P11 is nothing but first individual loop, P21 is nothing but second individual loop, P31 is nothing but third individual loop. So within this parenthesis we are going to add all the gains of this individual loops. Means we need to determine from sake of observation ki how many number of loops we are having. If we are having the n number of loops, so all these loop gains are being added within this first parenthesis, right? As far as this second parenthesis is concerned, So what it is P12 plus P22 plus P32, right? So how to remember this second parenthesis? Similar to the first parenthesis, it is the first individual loop gain, second individual loop gain, it is the third individual loop gain, right? As far as this P12 is concerned, so P12 is basically, it is nothing but what? It is the gain product of two non-touching loop, right? P22 is nothing but it is the gain product of second two non-touching loop. P32 is nothing but again it is the gain product of third two non-touching loops. Means within this second parenthesis we can say that it is the sum of all gain products of two non-touching loops. What it is? It is the summation of gain products of two non-touching loops. It is first two non-touching, second two, and third two non-touching loops. Similarly, third parenthesis is nothing but what? It is the extended version of that second parenthesis. Again, it is the summation of all gain products of three non-touching loops. Means here P13 is nothing but it is the gain product of first three non-touching loops. P23 is nothing but it is the gain product of second three non-touching loops, and similarly P33 it is the gain product of third three non-touching loops. So in this way this delta is being tabulated, right? After that one more parameter we are having, this delta I, right? So this delta I is nothing but the desired value of delta which will not touches to the ith number of forward path, right? That is nothing but delta I. If suppose it is delta 1, so delta 1 equals to 1 minus the desired part of this signal flow graph which will not touches to the first forward path, right? Laterly I will tell you the significance of this delta I, right? So for sake of this moment, in this way this Mason's gain formula is being used, right? So as we are having this signal flow graph representation, so in this signal flow graph representation, first of all we need to determine how many number of forward paths we are having. Forward path means what? As I told you earlier, somehow we can start our journey at this input and we need to terminate our journey at output. That is nothing but forward path, right? So here I will show the first forward path. When we will start our journey with this R, so this horizontal line represents the first forward path which is present in between R and C, right? Now this first forward path, that can be call it is as a P1, right? So P1 is nothing but the gain of first forward path. Gain in the sense we need to multiply all these terms with each other, those are present in between R and C, right? So there are how many terms? G1, G2, G3. Remaining terms are equals to 1. So the gain of that first forward path will become G1, G2 and G3, right? So similarly we need to find, from sake of observation, whether we are having any other forward path through which we can start our journey at R and we can terminate our journey at C, right? So this is the second forward path. With this R we will start our journey. Through this one we can go to this upper side, and again this is the forward path. Through this part we can come across to this C, right? One more thing which is remaining here, the gain of this path is exactly equals to 1, right? So this entire portion is nothing but the second forward path, that can be treated as a P2, right? So P2 equals to, simply we need to multiply all the branches which are present in between the second forward path. So 5, 6, 4 in ascending order we can write this. This is G5, G6 and G4. Remaining gain is exactly equals to 1. So these two are the forward paths, those are present in this signal flow graph representation. Apart from these two forward paths, we don't have any other forward path through which we can complete our journey from input towards the output, right? So this is the first step in which we had tabulated there are two forward paths we are having with us, right? So in that second step we need to determine how many individual loops we are having in this signal flow graph representation. So basically loop is nothing but what? It is the closed circulating path that can be called it as a loop. So from sake of observation we need to observe there are how many number of loops we are having with us, right? So obviously this will be the first loop. It is the closed circulating path. Loop means when we start our journey with this node, somehow at the end of this graphical representation part we are coming across to the same node from which we had started our journey, right? So that will be the first loop. Similarly this will be the second, this will be third, and this will be the fourth loop, right? So in that second step we need to determine number of individual loops. So this will be the first loop, see, and the gain of this loop will become what? The gain of this loop will be this g1 into minus of h1. So gain of first individual loop p11 equals to minus g1 times of h1, right? Similarly the second individual loop will be the next one. Here the forward path g2, feedback signal is nothing but minus of h2. So gain of second individual loop equals to minus of g2 into h2. Similarly this will be the third loop, that is nothing but g3, right? So p31 equals to what? Minus of g3 into h3. And one more loop we are having in this signal flow graph representation, that particular part. When we start at this node we will come across this node, and through this feedback again we will come across to that node from which we had started our journey. So how this loop will look like? In this way, this is g5 minus of h4. So the gain of fourth individual loop equals to minus g5 times of h4, right? So as we are having these four loops and their desired loop gains, right? Then after that, as far as this Mason's gain formula is concerned, so first parenthesis is being tabulated, the gain of first individual loop gain, second individual loop gain, third individual loop gain, and fourth individual loop gain. Now we need to come across towards this parenthesis number 2. So as I told you earlier, parenthesis number 2 is nothing but it is the sum of gain product of two non-touching loops, and parenthesis number 3 is nothing but it is the gain product of three non-touching loops. Means in that third step we need to determine the parameters belongs to parenthesis number 2, that is nothing but the gain product of two non-touching loops. In the sense we need to determine there are how many two non-touching loops we are having with us. So basically as far as the signal flow graph representation is concerned, non-touching loops means they are not sharing the similar node as well as they are not sharing the similar elements, right? So for that purpose let us compare these four loops with each other, right, to complete our third step, that is nothing but what? The gain product of two non-touching loops, those are being included within that second parenthesis, right? So when we compare p11 and p21, so they are sharing the similar element, that is nothing but what? Here p11 equals to g1 times of minus g1 times of h1, and p21 equals to minus g2 times of H2. But as you can see, they are sharing the similar node, means we cannot say that these two are the non-touching loops because they are sharing this particular node. This node is a part of first loop as well as second loop. But when we compare first and third, so at that time we will come to know that these two loops are the non-touching loops because they are not sharing the similar elements as well as they are not sharing the similar node. These two loops has nothing to do with these similar nodes. They are not sharing the similar node, right? So here the product of these two non-touching loop, that can be rewritten as a P12, right? So P12 is nothing but P11 into the third loop, that is nothing but what? P31, right? So P11 equals to what? It is minus G1 into H1 into P31 equals to minus of G3 into H3. So it will become G1 G3 H1 H3. This minus minus will become plus. So this P12 is nothing but what? It is the gain product of these two non-touching loops, first parameter of this second parenthesis. Similarly, when we compare the first and fourth loop, right? So again they are not sharing the similar elements as well as they are not sharing the similar nodes, right? So the next quantity within this parenthesis number 2, it will become P22, right? The second two non-touching loop. So what it is the gain product of second two non-touching loops. So P11 and fourth one, that is nothing but what? P41. First individual loop and fourth individual loop, they are non-touching to each other. So their gain product will be what? First is nothing but minus of G1 H1, fourth is nothing but minus of G5 H4. So directly here I will write, it will become G1 G5 into H1 H4, right? Now after that, whether we are having again any two non-touching loops, when we compare this second loop with this third loop, so they are sharing this similar node, so they are not falls under the category of non-touching loop. Here when we compare the second loop and third loop, so they are sharing the similar node, so they are not fall under the category of non-touching loop. But when we compare the loop number 2 and loop number 4, right, as well as when we compare the loop number 3 and loop number 4, right? So loop number 2 and loop number 4, that can be called as a non-touching loop, as well as the remaining pair of two non-touching loop will be loop number 3 and loop number 4, right? So the next term which is written within that second parenthesis, that is nothing but what? P32, right? What this P32 stands for? It is the gain product of third two non-touching loop. So third two means what? Second one and fourth one. Second the loop gain of that second loop will be what? P21 into fourth one, P41, right? So here we are having P21 minus G2 into H2, P4 minus G5 into H4. So as a result of multiplication, it will become G2 G5 into H2 H4. That will be the gain product of third two non-touching loops. Again, as I told you earlier, when we compare fourth one, third one and fourth one, so again it is a pair of two non-touching loops. So this will give you the gain product of fourth two non-touching loop, that is nothing but third individual loop gain P31 into P41. So P31, what it is written, it is minus G3 into H3 and P4 minus G5 into H4. So it will become G3 G5 into H3 H4, right? So this is all about the second parenthesis of this Messer's gain formula, which will tell us the gain product of two non-touching loops. Gain product of first two non-touching, second two non-touching, third two non-touching loop, and fourth two non-touching loops, right? Then immediately after that we need to determine the third parenthesis parameter, the gain product of three non-touching loops, right? So when we compare these four loops with each other, right? So out of that four loop, right? So here, out of this four loop, we can say that this is the first, second, third, and fourth. What we need to determine, the parameter belongs to the system determinant, the sum of gain product of three non-touching loops, right? So out of this four loop, 1, 2, 3, and 4, when we compare first loop, third loop, and fourth loop, so at that time we will come to know that these three loops are neither sharing the similar node nor they are sharing the similar elements. Means these three loops falls under the category of three non-touching loops, right? First loop, third loop, and fourth loop, right? So in this way, right, within the same step, step number 3, we will get the third parameter of this third parenthesis, that is nothing but what, P13, the gain product of first three non-touching loops. So first three non-touching loops, in the sense this loop number 1, loop number 3, and loop number 4. So we need to multiply this loop, so it will become P11 into P31 into P41. So their gains are being already tabulated. We need to multiply these gains, so it will become this minus minus plus, and again it will become minus. So overall it will become minus G1 G3 G5 into H1 H3 H4, right? This is the parameter belongs to the system determinant delta, right? So now in that next same step, step number 3, we need to determine the desired value of this delta, right? So delta equals to what here? It is 1 minus sum of individual loop gain plus gain product of two non-touching loops minus gain product of three non-touching loops. So these parameters are being already tabulated. Simply we need to put these values. So it will become, see, 1 minus we are having 4 different loops, right? So their gains are nothing but what, P11 equals to minus G1 into H1, P21 equals to minus G2 into H2, P31 equals to minus G3 into H3, and P4 equals to minus G5 into H4, right? Plus the gain product of first two non-touching loop, second two non-touching loop, third two non-touching loop, and fourth two non-touching loops. Here we need to write, it will become P12, P22, P32, and P42. So it will become G1 G3 H1 H3 plus G1 G5 H1 H4 plus G2 G5 H2 H4 plus G3 G5 H3 H4. The gain of first two non-touching loops, second two, third, and fourth two non-touching loops, minus in that third parenthesis we need to write the sum of gain product of first three non-touching loops. So it is P13 already, it is being tabulated, so it will become minus of G1 G3 G5 H1, H3, H4, right? So here delta will become what? This minus minus will become plus, so it will become 1 plus G1 H1 plus G2 H2 plus G3 H3 plus G5 H4 plus, as it is, this term is being written G1 G3 H1 H3 plus G1 G5 H1 H4 plus G2 G5 H2 H4 plus G3 G5 H3 H4. This minus minus lastly will become plus, so it will become G1 G3 G5 H1 H3 and H4. So this all quantity is nothing but your system determinant delta. Okay, so lastly we need to determine these factors called as a delta 1 and delta 2, right? Because Mason's gain formula is nothing but what? It is 1 over delta into summation of pi into delta I, right? So I stands for what? Number of forward path, right? So already we had defined we are having two forward paths, right? This is P1 and P2. So here I will write these two forward path. P1 equals to G1 G2 into G3 and P2 equals to G5 G6 G4, right? So accordingly we need to determine this delta 1 now, right? So delta 1 is nothing but, as we know, G1 G2 G3, this is the forward path number 1. So as I told you earlier, delta I means delta 1, right? According to the forward path number 1, delta 1 is a desired part of this signal flow graph which will not touches to forward path number 1, right? So here forward path number 1 is nothing but this entire horizontal line starting from R to C, whose gain is nothing but G1 G2 G3, right? So we need to determine the desired part of the signal flow graph, or meanwhile we can say that whether we are having any particular loop which will not touches to forward path number 1, right? So definitely we can say that this loop has nothing to do with this forward path number 1, right? The loop gain is what? Here the gain of this loop is nothing but minus G5 times of H4, right? Which has nothing to do with this forward path, whose gain is exactly equals to what here? G1 G2 G3, right? So ultimately we can say that delta 1 equals to 1 minus of that desired loop gain which will not touches to forward path number 1. So that loop is nothing but this loop number 4, whose gain is nothing but minus G5 times of H4, which has nothing to do with this forward path number 1. So our delta 1 will become 1 minus of minus G5 into H4. So it will become delta 1 will become 1 plus G5 into H4. Similarly, as we are having two forward path, so we need to determine delta 2 also, right? So delta 2 means what? Our forward path number 2 is nothing but G5, G6 and G4, means this upper portion G5, G6 and G4, right? So here we need to determine, right, according to forward path number 2, whether we are having any loop gain which will not touches to this forward path number 1. That is nothing but what? Our delta 2. Delta 2 is nothing but the desired part of the signal flow graph, which has nothing to do with forward path number 2, whose gain is nothing but G5, G6 and G4. Right. So clearly we can say that here, as far as this first loop is concerned, right, which will share this particular node in that forward path number 2 and this loop gain, right. So definitely we cannot map this first loop as a part of delta 2, right, because it will touches to this particular node, means we cannot say that it has nothing to do with this forward path number 2. It is a part, or this node is a part of forward path number 2 as well as this loop gain also, right. So that cannot be treated as a part of delta 2. But when we come across to these two individual loops, loop number 2 and loop number 3, whose gains are nothing but what? The gain of this loop is nothing but minus G2 times of H2, right, and the gain of this loop is nothing but minus G3 times of H3. It has nothing to do with this forward path number 2, whose desired value is nothing but G5, G6 and G4, right. So definitely these two statements can be written as a part of delta 2, right. So here delta 2 will become 1 minus the third loop gain, that is nothing but minus G2 into H2, right, minus the fourth loop gain, that is nothing but what? Minus G3 into H3, right. So the overall value of this delta 2 will become 1 plus G2H2 plus G3 into H3, right. So in this way delta 1 and delta 2 is being tabulated. So according to this Mason's gain formula, the overall transfer function is nothing but, as we are having two forward paths, P1 into delta 1 plus P2 into delta 2 divided by delta, right. So P1 equals to what here? It is G1, G2, G3 into delta 1, that is nothing but what? 1 plus G5 into H4 plus P2 is nothing but G5, G6, G4, and delta 2 is nothing but, sorry, here I will write delta 2 is nothing but 1 plus G2 H2 plus G3 H3, right. This is the numerator of this transfer function, P1 into delta 1, right. This is P1 here, and this is delta 1 plus P2 into delta 2, this is P2 and this is delta 2, and as far as its denominator is concerned, so we need to write this whole term, right, which is already tabulated, right? This delta, this whole term is written within this denominator. So this will give you the overall transfer function, right. So this is all about the signal flow graph technique. So I just hope that you will get clear idea about this signal flow graph technique by taking into account this basic example, right. If you are having any suggestions regarding to this lecture, kindly post your suggestion in comment box. Thank you.